This video is the beginning of our lecture on database security. Before we can talk more about database security, we're going to need to understand data security in general. So this is the protection of all data, all digital assets from accidental, passive, or intentional loss, destruction, or misuse. Accidental loss could occur with some programming logic that is done incorrectly or someone who's working in the wrong environment. In fact, we shouldn't have people have access to the testing environment and the production environment. We should have kind of a least privilege where certain people only have certain access to certain environments and certain other people have certain access to other environments. But this wasn't the case in one of my jobs where I was a database developer and I worked in both the testing and the production environment. And one time I thought I was working in the testing environment and my routine was to wipe one of the tables clean so that I could start new and test new implementations of our user interface that interacted with our database. However, one time I was working in the production environment and I didn't realize it till it was too late when I wiped the entire table clean. Luckily, we had it backed up so we could restore all the data and only lost like an hour of productivity. Passive would occur when someone knows the rule, such as that they shouldn't write their passwords down, but they do anyway, and then those passwords are easily retrieved, maybe they're under the keyboard, etc., and then anyone who has access to this post-it note can then access the database. Intentional loss would be someone who actually wants to do some harm to the organization, such as hackers or maybe some disgruntled employee. And then we have destruction, which could occur from like some major disasters such as a tornado or hurricane, and then misuse would be employees that are just not doing the things that they should be doing. So as part of security, we need to establish three fundamentals. This is known as the CIA triangle. No, does not refer to one of the national agencies. The CIA triangle consists of confidentiality, which means that we want to keep sensitive information protected, meaning that while we are either storing, transmitting, or processing this information, it should only be allowed to be accessed by the people who should have access to it. We want to ensure that it has integrity, meaning that the information is intact and valid, meaning that it is what it is supposed to be, that there have not been any alterations to the data that should not have been made. The third, which comes from the A, is availability, meaning that we can keep the information available and accessible 24/7. Now, this comes at a great cost. The more that we want to establish 100% availability is going to cost us a lot more. In fact, 100% is most likely unachievable, but we want to ensure that we have availability for the most part. There's also additional part, which is another A, which stands for accountability, which allows us to map the system actions to responsibility. So for example, as a user engages with the database or engages with some kind of aspect of our environment, we're going to log all that so that if something bad does happen, we can look at our logs and determine what happened or went awry. Alright, so as part of data security, we have several threats that could ruin our data. And there are several locations where these threats can occur. So first of all, we have the database server, where we host Oracle, MySQL, SQL Server, Informix, a bunch of other databases. And then we're going to have an internal firewall that's going to restrict all access to the database server to only those employees that should have access to the database server. Then we're going to have middleware servers such as PHP, ASP, JSP, and a bunch of other programming languages that could directly interact with the database server. The internal firewall would allow the connection to this middleware server. Then we have the web server that uses Apache or Microsoft IIS to run the web server. In this class, we're using Apache. The web server would then connect to the middleware server, such as PHP for what we're using in this class, which would then connect to the database. Then we have a perimeter firewall, also known as the border firewall, that restricts all access from those outside of our network to have any other access to our network other than through a particular web server or other applications that we indicate that the users have access to. And then the user is going to connect to the web server through the browser using Chrome, Internet Explorer, Firefox, Safari, Edge, a bunch of other browsers out there. Okay, so these are the fundamental basics of our database environment and everything that connects to it. Now let's look at the particular threats at each one of these areas. So the first threat with the database server is that we could have people with more permissions than they should have. This could be a huge issue because they would be able to access data that they shouldn't be able to access or change or do anything with that data that they shouldn't be able to. The next thing that a person can have is weak permissions, meaning that they're able to access folders or contents that they shouldn't be able to access because we don't have those restrictions on the permissions. Additionally, we could have open ports in our internal firewall that shouldn't be open, or even be the default ports that people can access our database server through. We have eavesdropping that could occur through transmission, so anyone who's sitting there wiretapping could capture any transmission that's going through. But there are a bunch of different ways that people could capture this information as it's going to the database server. Again, on the middleware server, we could have people with overprivileged accounts, meaning that when they log in, they could access administrator rights. Additionally, we may not validate some of our inputs. So even though the form could take drop-down menus, we still need to validate it behind the scenes because those form values can be overridden, meaning that someone could pass anything through that form even if we restrict it to just what's in the drop-down. And so we want to make sure that we have validation take place on the middleware server. As far as the web server, we need to make sure that we authenticate the users using passwords. We need to protect against SQL injections, which we'll talk about in a later video. And we want to make sure that we protect against denial of service attack. So if our web server is under a massive array of attack, we can handle it so it doesn't go down and so we don't lose business. And then just like on the internal firewall, we have the perimeter firewall that could have open ports or default ports that we should change so that people cannot access or come directly through our network through some weak points. And then finally, we have that hacker that could come through, use any of the weak points that we just discussed to have access to our database server. And that's when things get interesting, where you hear of those million records that have been released to the web. All right, some major security features that we need to consider and we'll talk about in subsequent videos are authentication. So making sure that we have the proper passwords and the way that we handle those passwords so they can log into the system and we can maintain confidentiality. The second is authorization. We want to make sure that people only have the privileges that they should have. We want to ensure a rule of least permissions, meaning that we give people enough permissions to do their job and only enough permissions. We want to ensure that we have availability so that people can continue to access the resources and so they can engage in the transactions. We want to ensure that we have integrity so that people, when they come to our website, they enter in valid information into forms, and so that we can actually ensure that our data is the way it's supposed to be. The next thing is encryption. As we're putting data into our database through transmission, or as we're storing passwords, etc., we need to properly encrypt that so the user's data is encrypted. Even if it's captured, it will not be able to be read. And then finally, we'll talk about recovery. And recovery allows us to restore our database and our files back to normal. We should ensure that we have some recovery procedures in place because it's bound to happen that something bad is going to happen, even if it's accidental, so that we can recover our database back to where we need to.